Hello everyone and welcome to the third video in the Earth Science Review series. This is Unit 2 still, describing Earth, and this video is just going to touch on how to draw isolines and how to calculate gradients. So it's going to be hopefully a little shorter than the other videos, but focusing on two very important skills. So here we go. Question 1. Base your answer to the following question on the topographic map, and your knowledge of Earth science. Points A and B represent location on the Earth's surface. So we got A, which is located down here, as you can see, and B is located over here. Elevations are shown in feet. That is very important right there. Elevations are shown in feet. So we want to make sure that we take a note of that. Just want to make sure my pen works. Okay, there we go. The elevations are shown in feet. It says the 50 and 55 contour lines are not shown on the map, which is fine. Contour lines are lines that measure elevation or height, and these come up a lot, so you have to relate the word contour to elevation or height. So it wants us to draw the 50-foot and the 55-foot contour lines. They must extend to the edges of the map. So there's two ways to really start tackling this. The first way is to find all the 50s. So we're going to do the 50 line first. So 50, 50, 50, I see 3, 4, 50. Okay, so the idea is you want to connect these points together. And by the looks of these 4 dots, it's going to make some sort of line. Normally you can look at the other isolines, like see how the 70s align, the 65s align, the 60s align. Generally speaking, all the isolines are going to look similar. So if you see isolines that are circular on a map, chances are that you're going to be creating circles. If you see isolines that are line-shaped on a map, chances are you're going to be making lines. So in this case, we're going to be making a line. So as I draw the line, which I'm going to start from the edge of the map and get to the first 50, I have to get down to this 50 here. But here's the rule. When you go between two dots, as I'm about to go through, I'm about to go through the 48 and the 52. The number 50, if you count 47, 48, 49, 50, 51, and then 52, the number 50 is in between 52 and 48. Therefore, my 50 line must go between this 48 and this 52. It has to go in between those because the number of 50 is in between 52 and 48. Now, I can't go this way because that would be putting 50 between a 47 and a 48. And the number 50, if you count, is not between 47 and 48. So I have to go in between 52 and 48 to get that number 50. And the reason I went through those two numbers right here is because 50 is in between 52 and 48. Therefore, my line must go in between those two numbers. So now I go down here. I have to get this 50. And I have to get this last one down here. Now I can't go this way because 50 is not in between 49 and 47. So that's illegal. So I have to go this way, which is going between 54 and 49. So that's why I'm going to extend the line down here. And then I can't leave that line hanging. I have to bring it to the edge of the map. So this is a perfect 50 line right there. And a way to check it is make sure all the numbers on one side of the line are less than 50 and all the numbers on the other side of the line are more than 50. So let's check. So here's my 50 line. Look, 48, 47, 48, 47, 49, 48. All of those numbers right there are less than 50. So I did that right. And all the numbers on the other side are more than 50. So that's the way to check. So 50 is done. So now we'll do 55. So we got 55 and 55. So I have to connect those 2 points with a line plus run it off the page. So let's start at the top and get the 55. Now I have to make it my way all the way down here. So as I do it, I'm going to make sure that I go in between numbers that are bigger and smaller than 55. Like, here we go. 55 is in between 53 and 56. It's in between 53 and 56. It's in between 53 and 57. It's in between 54 and 56. So I could get my 55. And I don't I'm going to try to go through the dots and then run it off the page. Now, you're better off running it off the page a little tiny bit extra rather than worry about it not being enough, because if it's not fully off the page, it's going to be no credit. So those are the two there. We're not going to draw extra isolines. We're only going to draw the ones that the question asks for. Okay, so there's the first map. So now if we go on to question 2, it says calculate the gradient along the line from A to B. Now, gradient, the formula is on the front of your reference table. So gradient equals change in field value, the triangle means change in, divided by the distance. It's just a rate of change formula, except gradient is the measure of steepness or slope. So if it's a high gradient, that would mean you have a steep slope. And if it's a low gradient, that's a gentle slope, meaning it's flat. And steep would mean it's like a really big hill. It changes elevation in a short amount of time, so that would be like a cliff or something like that. So we're going to calculate the gradient from A to B. So we're going to find change in value. So that you find based on the iso line that the letter is on. So A is on the 100 line. So I'm going to start with 100, and this looks like meters. So it gives it right there, meters, minus B is on this line. Now, it doesn't tell you what value that line is, but the contour interval here is 10 meters, meaning each line goes up by tens or down by tens. So this is 100. That means this one's 90, which means this one's 80. And that makes sense because the 79 is a little bit before it. So B is 80. So we're going to do 100 meters minus 80 meters divided by the distance in between A and B. So we have to figure out how much distance is between A and B. And the way that we do that is we use the scale on the map. There's no way to do it without the scale unless they give you the number in the question. So in order for me to sort of demonstrate this, I'm going to try to use a invisible piece of paper here. So here we go. We're going to line this up here. Now, if you were on a test, you would take your loose leaf and you would line it up to this scale. And what we're going to do is we're going to mark the scale on our loose leaf paper. So in my case, I'm just going to do it in marker. So you have to bear with me. So we got 0, and then this one, and then this one, and then this one, and then this one. I'm pretty sure I can group that. I'll group my little marks on the paper. And sometimes it's good if you also label on the paper what the measurement is. So it'll just make it easier for you. So this is 0.4, 0.8, 1.2, and 1.6. So you take your loose leaf paper with your now drawn scale on it, and you take it, and you match it up to this line here. So in my case, I'm going to have to rotate it. So it looks like to me, this distance is between 0.4 and 0.8. So it looks like it's about 0.6 or 0.7, I would say, for the distance. So we could write that here. So let's do 0.7. And the unit here is kilometers. So there is my formula. So on my calculator, I'm going to do 100 minus 80, which is 20 meters, divided by 0.7 kilometers. And I'm going to get 28.57 as an answer. But my unit's going to be the top unit divided by the bottom unit. So it's going to be meters per kilometer. So that's my final answer. Now, your distance might not have been exactly 0.7. You could have put 0.65, 0.6, something along those lines, but you'll still be in the range of the answer key. So, but you want to try to be as exact as possible. Was my way doing this as exact as possible? Probably not. Yours is going to be way better on a piece of paper. All right, let's do the next question. On the map, draw the 60 and 70 meter contour line. Okay, so we know how to draw contour lines now. So we got to do the 60 and the 70. So let's find all the 60s. We have a 60 here, a 60 here, and a 60 here, and a 60 here. Now remember what I said before. These lines, there's one that goes like this, the 50 line goes like this, so my 60 line is probably going to do something like that. So here's 60, and I'm going between 56 and 63. Be able to get this 60. There's one here. So I got to get from here to there. So I'm going to go between 55 and 69, between 55 and 68, and get that 60. And then I'm going to go up between the 57 and the 68. Now I can't go this way because 60 is not in between 61 and 70. So I'm going to go between 57 and 61 right here, between 57 and 63, between 58 and 63, and then get this 60 right there. There's no other way to go because you can't go in between numbers that aren't around 60. So now I got to get from this 60 to this 60. So I'm going to go between 58 and 73 and get this 60. Now there's no more 60s, but I can't just leave my line hanging there. I got to run it off the page. Now I can't run it off the page right here because that would be going between a 53 and a 58. 60 is not in between 53 and 58, but it is in between 57 and 64. So that's where I'm going to run it off the page, right here. Because again, 60 is in between 57 and 64. So there's my 60 line. Now I got to do 70. So same process. Here's a 70. Do I see any? Here's a 70. And here's a 70. So 70 is in between 71 and 69. So I'm going to start here and get this 70. I can't start here because 70 is not in between 67 and 69. So 70 is in between 69 and 72. So I'll go through there. 70 is also in between 68 and 73, and then I'll get that 70. 70 is between 69 and 79, and then I got to go up this way because 70 is in between 75 and 68. And then I'm going to go between 68 and 75, between 68 and 73, go underneath here, go between 65 and 74, and then between 67 and 75. As you could see also, my isolines cannot intersect. That's not allowed because you can't have a line that has two different values. If this 70 line intersects with this 60 line, that would mean at this spot here, the values 60 and 70 at the same time, which is impossible. So there's your 60 and 70 contour lines. Very good. All right, number 4. On the field map, draw 3 isotherms. 23, 24, 25. Okay, we're going to do this one a little quicker. Let's start with 23. 23, 23, 23. Good. So we're going to start from the edge of the paper, grab the first 23, get the second one. Try to go through the dots if you can. Then we're going to get this 23. We're going between 24 and 22. Go between 22 and 24 here. Go between 21 and 24. Go between 22 and 24. Between 22 and 24. And then stop. I can't go anywhere else. I can't go up and over because then I'm starting to go near the 26s. And 23 is not near that number. So this is generally where it is. 23 is good. All right, 24. Here we go. Start at the top. 24, 24, 24, 24. Loop around and get this 24. And I missed that dot. See, that's bad. So you don't want to miss the dot. 24, 24, 24. There you go. And then 25, 25, 25, 25, 25, and 25. Notice when I just drew my 25, like we're going to check like we did the last time. All the numbers on one side are bigger, and all the numbers on the other side are smaller. So that's all done. So there's my 3 lines. And now, calculate the temperature gradient between A and B. So we know how to do this. Gradient is change in field value over distance. So my change in field value is going to be A is 27 and B is 24. So 27, it says it's in degrees Celsius on the top. You always need a unit. So if you don't know the unit, start checking everywhere. Check the reading, check the map, see if there's a key somewhere. So there's 27 degrees Celsius minus 24 degrees Celsius over the distance. Now to get the distance, remember we got to use the scale and our scrap piece of paper. So I have my little scrap piece of paper here. We're going to do the same thing I did last time. I'm going to take our scrap paper, line it up to the scale. Try not to use the edge of the scrap paper when you do it, because it's not going to be as accurate. So we got 0, 1, 2, 3, 4. Okay, so now I'm going to take that and group it up so I can move it. Except we don't want that. We don't want the stray marks. We just want our number line. Group that. Okay, so we got to see how far A is from B. So we're going to do our best with my little method here. So it looks like a little more than 2. 2.1 or 2.2. I like 2.2. Or maybe 2.1. Let's try 2.1. So 2.1. Got to use my pen. 2.1. And what's the unit for that? Well, it's whatever is on the scale. And in this case, of course, my paper is blocking it. Why wouldn't it be? Meters. There it is. Meters. And I don't have my pen. 2.1 meters. Sweet. So now I'm done. So just solve my question. 27 minus 24 is 3. And we're going to divide 3 by 2.1. So I'm getting, it looks like, 1.42. And my top unit's degrees Celsius. And my bottom unit is meters. So there's my gradient, 1.42 degrees Celsius per meter. And what this reads, this is saying that every meter that you travel on this map, the temperature changes by 1.42 degrees Celsius. That's what that means. The change is 1.42 degrees Celsius per 1 meter that you go. All right, so that's a little overview on isolines and gradient. The test is going to consist of the spheres, locations, so you can watch that video. That was video number 2, plus drawing the isolines and doing a couple gradient questions. So I hope you found this helpful, and I will catch you on the next one. See you later.